Beneath California's calm surface, a hidden pressure is growing. NASA now sees new movement and rising strain along the San Andreas, warning signs the fault may be gearing up for something serious.
Much of the land beneath our feet is sinking, and it's sinking faster than ever before. And what's more, the federal scientist behind the study says that this sinking land could cause some problems for what we build on top of it.
Beneath the golden sun and sprawling cities of California, a silent threat is gathering power. From the outside, life goes on. Highways pulse with traffic, redwoods stretch skyward, the Pacific breeze sweeps through fields and forests. But far below, out of reach to the ordinary eye, invisible forces are at work. Forces strong enough to transform landscapes, fracture mountains, and topple everything humans have built. The ground that seems so steady is, in truth, balancing on the edge of immense tension. Recently, NASA's satellites, eyes sharper than any on Earth, have detected something unprecedented: new signs of movement and sudden shifts along the infamous San Andreas fault, accompanied by changes in strain that demand immediate scientific attention. At the same moment, a mysterious interstellar visitor unleashed a flash of radiation so strong it briefly overwhelmed sensors in orbit. Within days, scientists uncovered something even more chilling: a rapidly accumulating strain surging through the fault line, far beyond what's been seen in decades, pointing not just to the risk of an earthquake, but to the possibility of catastrophic events unlike anything in recent California history. What does it mean when the universe itself sends a shockwave and Earth's crust strains to the breaking point? Could it be coincidence? Or are these signs of forces larger and deeper at work? A warning written in the restless bedrock beneath our feet. As concern mounts and experts search for answers, you'll witness every revelation, every twist, and every scientific secret that now threatens to reshape everything we know about California's and Earth's future. Because when the ground trembles and satellites register sudden warnings, the only question left is, are we already too late to stop the coming disaster?
Chapter 1.
San Andreas Fault on the Brink. NASA satellites have detected a marked increase in fault movement right along the infamous San Andreas. The measurements aren't subtle. They show a visible uptick, traceable from the Salton Sea to the mountains north of Los Angeles. For decades, California's most dreaded fault has been quiet. Too quiet. But now, the ground itself seems restless. Is the San Andreas fault about to unleash the nightmare event seismologists have always feared? What NASA's satellites are picking up is clear: rapid accumulation of strain at levels not seen in recent memory. The plates on either side, Pacific and North American, are not simply drifting past each other in their normal rhythm. Instead, stress is locking up. When faults behave this way, history shows there's rarely much warning before disaster strikes. The build-up, invisible to ordinary senses, can explode into devastation in mere seconds. And now, with satellites confirming those invisible shifts, scientists must confront a chilling possibility. The next big one may be much closer than anyone dared to imagine. Across California, researchers assemble in emergency meetings at Caltech, Stanford, and the US Geological Survey headquarters. Computer screens flicker with fresh data and colorful satellite images, displaying movement patterns and strain buildup, almost like a seismic graph writing its own prophecy of chaos. Decades of infrequent tremors have lulled the public into a fragile sense of calm, but now, stress is curling beneath the surface. Experts have begun referring to the locked and loaded state of the fault, a phrase that sends a chill through emergency planners. Major fault segments may now have built up more energy than at any point since the 1906 San Francisco quake. All eyes turn south, toward the starting point of so many historical ruptures, the southern San Andreas. There, according to the most recent radar data, a line of strain carves a signature across hundreds of miles. The Earth is holding its breath.
Chapter 2. Earthquake energy building up.
Imagine gazing at a city skyline, knowing a hammer is swinging towards its foundation, indiscernibly, but with unstoppable force. That's the reality geologists now face, as NASA's satellites chronicle the San Andreas' change. Suddenly, earthquake energy is coiling beneath California. Could a single rupture trigger devastation across hundreds of miles? To answer, experts study how energy collects inside faults. As tectonic plates grind and then lock, stress accumulates. Normally, it releases with numerous smaller quakes, but sometimes, as data now suggests, pressure refuses to give way. An ominous silence, the build-up sharpening beneath the world's gaze. Satellites reveal not just where the fault is moving, but how strongly energy is stacking up in its core. When finally released, that energy can topple buildings and send shockwaves across vast regions, consequences felt far beyond the rupture zone. Recent studies confirm that once released, seismic energy doesn't confine its fury to a straight line. It radiates outward in waves. These waves ripple through rock layers, bouncing off ancient geologic boundaries, sometimes amplifying in sediment basins beneath major cities. There, the shaking can intensify, impacting buildings, roads, and critical infrastructure beyond the initial tremor's path. Geologists estimate that enough elastic energy has gathered in parts of the San Andreas to power not just a single earthquake, but potentially a sequence of major quakes over a broad area. This interconnected tension suggests that unless relief comes gradually, California could be facing a chain reaction. The consequences are immense, not just for the landscape, but for every community resting atop these ancient fault lines. Residents trained in earthquake drills may one day wake up to the reality that the disaster they've practiced for is more massive and more sudden than anyone expected. Chapter 3. Satellites stunned. Cosmic shockwave strikes. For a brief moment, the world's most advanced satellites lose clear sight. Sensors, designed to withstand harsh radiation in space, are briefly overwhelmed. A cosmic event powerful enough to disrupt Earth's eyes in orbit. What could have caused even NASA's finest instruments to falter? Scientists comb through data logs. The culprit, a burst of radiation from a mysterious object arriving from beyond our solar system. Its intensity is extraordinary, briefly flooding the satellite's detectors. In cosmic terms, it's a lightning strike, a rare event. As NASA's team studies the timelines, they make a startling observation. The radiation burst and a surge of strain along the San Andreas occur almost in parallel. Is this merely coincidence, or a clue to a much deeper connection between Earth and the cosmos? Astronomers trace the cosmic burst to a high-energy source, such as a remote neutron star collision or a flaring magnetar. The radiation, composed of charged subatomic particles, bombards Earth's magnetosphere before fading. For a few key moments, sensors on multiple satellites, including ground-based instruments, register static, noise, or momentary blindness. Around the world, observatories compare notes. Such a cosmic event timed so closely with an apparent increase in tectonic strain is extremely unusual, and it sparks new debate among researchers. Some experts begin to discuss whether intense cosmic rays and radiation can influence Earth's geosystems. For now, mostly hypothesis, but the timeline's overlap prompts new research questions. For the first time, a burst from beyond our solar system and an Earth-bound seismic warning seem to coincide, challenging long-held ideas about the isolation of planetary events. Chapter 4. Strain Mapping. NASA's Hidden Warnings. As the numbers spike, the maps begin to tell a worrying new story. Data from satellites pours in as NASA's scientists chart each subtle shift, each tightening of the fault. The San Andreas isn't just moving, it's transforming in ways not previously seen. Are strain maps predicting our next disaster before it happens? This question now drives research. NASA's radar satellites deploy the technique known as INSAR, interferometric synthetic aperture radar, to catch even the tiniest changes in surface elevation. When scientists overlay new data on maps from previous years, the pattern is alarming. The San Andreas' stress is now concentrated in precisely those areas long considered dangerous. With every scan, a digital warning grows sharper. Researchers study digital terrain models and animated strain maps that reveal a restless landscape. In the San Bernardino Mountains, ground once thought unchanging now pulses with invisible energy. Across the Coachella Valley, minuscule shifts in elevation track deepening pressure intrigued. These revelations enable scientists to identify not just the obvious risk zones, but new, previously hidden hotspots, where the Earth's crust is unusually thin or riddled with old fractures. Local governments receive alerts. Emergency planners begin consulting these maps regularly, plotting evacuation routes and pinpointing vulnerable bridges, dams, and infrastructure. It is a future where satellites double as oracles, broadcasting warnings that could, in effect, offer days or even hours of advance notice if rapidly updated and interpreted.
Chapter 5. The Science of Fault Blocking. Deep below California, the San Andreas is stretching, pulling, a geological tug-of-war. Some fault sections slip, others freeze, tension winding tighter every year. How does this hidden locking set the stage for disaster? This is geological suspense at its core. When faults lock, tremendous stress accumulates. This is invisible from the surface, but can now be tracked with precision by satellites. One side of the fault inches north, the other lags behind. The strain intensifies with every year of quiet. The longer the lock, the higher the chance that when the fault finally moves, it's not a gentle shift, but a powerful, landscape-changing quake. Detailed study shows these locked segments, sometimes 10 miles or less in length, border creeping zones that move slightly, acting as fuses for stored energy. Scientists model how stress accumulates unevenly, concentrating force at boundaries between creeping and locked fault sections. These boundaries aren't just points of interest, they may determine the timing, strength, and direction of a future earthquake. The longer these locked stretches hold, the more devastating their eventual release could be, sending shockwaves along the length of the state and possibly beyond. Seismologists liken the San Andreas to a loaded gun, its trigger delicately balanced on mounting stress, waiting for the smallest nudge.
Chapter 6. Silent warning. Microquakes beneath LA.
In the shadow of skyscrapers and traffic, the Earth trembles. NASA's satellite data captures swarms of tiny microquakes, too small for people to feel, but plain as day in the scientific records. Could these silent shivers be an early warning? Nature's encoded signal from the depths? Each microquake is a blip in the seismic record, a signal that the fault remains restless. While they rarely cause surface damage, clusters of microquakes can point to shifting patches of stress, revealing the invisible boundaries where larger breaks may eventually form. Scientists analyze patterns, knowing these clusters are sometimes the only notice that the system is preparing for more significant movement. Microquake swarms are well known, but their recent frequency and locations beneath major infrastructure, hospitals, interstates, transit hubs, raise concern. Scientists now use AI and machine learning to analyze huge troves of seismological data, seeking early signs, unique foreshocks that have often preceded catastrophic events in the past. Research into changes in frequency, wave amplitude, and seismic tone may help decipher warning codes hidden deep in the Earth.
Chapter 7.
The Salton Sea's disturbing signals. East of Los Angeles, the Salton Sea is a place shaped by both tectonic and volcanic forces. NASA's most recent data now registers unexpected surges, strange ripples that shouldn't be there. Could the seeds of a future superquake originate here, hidden beneath salt flats and desert haze? The Salton Sea sits at a junction between spreading ridges and the southern San Andreas. Recent strain readings show rising pressure in underground channels. This could signal either fault movement, changes in subsurface fluids, or the approach of a new rupture zone. There is growing concern among scientists. Could magma be shifting underneath, or is the fault simply entering a new, more dangerous phase? Teams equipped with mobile seismic stations rush to take new measurements. They monitor tremors accessible only to modern sensors,
trace faint gas clouds from old geothermal vents, and study the chemistry of the Salton Sea's waters. Recent detection of deep carbon dioxide emissions, a possible sign of nearby magma, adds to fears that rising heat and pressure could affect the fault. Some simulation models put the Salton Sea at the center of a potential domino effect, a rupture that could ignite movement along the southern San Andreas and spark a disaster for cities from Palm Springs to Los Angeles.
Chapter 8. Interstellar Visitor, Radiation and Earthquakes. A traveler from deep space swings through our corner of the galaxy, releasing a blast of radiation strong enough to momentarily confuse NASA's orbiting sensors. It's a rare, blinding cosmic burst. Could such forces from beyond the solar system ever trigger movements in Earth's crust? The question is captivating, though the answer remains uncertain. Astrophysicists and geophysicists compare notes as the timing between the radiation burst and mounting tectonic strain is noted. Whether the overlap is mere coincidence or a clue to an unknown relationship between geologic and cosmic forces remains a mystery for now. But the event prompts serious inquiry. Researchers dig through global seismic records. Correlations between cosmic ray events, solar flares, gamma-ray bursts, and seismicity have been the subject of limited, speculative study. Conclusive proof remains elusive, but the idea that the Earth's crust, already under tension, could be influenced by external high-energy events remains an active line of research, with increased funding and collaboration across scientific fields.
Chapter 9. Pressure Points, the Cascading Threat. NASA's satellite data adds detail. Strain is not distributed evenly. Certain fault patches, like dominoes, now appear ready to go. Which pressure zones could unleash a chain reaction across California? Maps show specific locked fault segments accumulating the highest energy, particularly underneath heavily populated regions. Scientists warn, when one segment ruptures, others could quickly follow, setting off a chain of multi-fault events. History supports this. The great 1906 San Francisco event and others have all shown the domino effect in action. Today's readings, with unprecedented strain, make the prospect of a multi-segment disaster all too real. Geological teams hike the zones, collecting GPS and gravity data, charting undulations invisible from above. They uncover evidence of ancient quakes, offset streams, out-of-place boulders, long tilted ridges. With each new finding, the grim scenario becomes more possible. A slip at one pressure cooker segment could jump the fracture to adjacent faults and amplify destruction. Chapter 10. Volcanic Hotspots, a Parallel Danger. Away from the fault lines, NASA's data reveal hints of volcanic activity in the same restless region. Hidden hotspots reflect patterns like those once seen along the Pacific Plate. Could rising magma be a silent threat, compounding the state's risk from below? Just as volcanic processes weakened the Pacific Plate in the distant past, minor magma upwellings now appearing may be generating abnormal strains near the San Andreas fault. With satellites able to catch small surface deformations, evidence mounts that weaknesses may be developing away from the main fault. While the interaction between magma and fault strain is complex, increased gas emissions and localized ground inflation at places like Mammoth Mountain and Long Valley Caldera suggest a need for heightened monitoring. Scientists hypothesize that deep magma bodies, under certain circumstances, might interact with fault mechanics to affect earthquake rupture timing. The system remains highly complex, and while volcanic activity is not imminent, such factors add another unpredictable layer to the region's seismic risk.
Chapter 11.
Rewriting the Earthquake Rulebook. As concerns mount, geologists and disaster officials confront a sobering truth. Many of their rules are becoming outdated. Are our foundational assumptions obsolete, given what NASA's satellites now show? With each satellite reading and every new microquake, the need for rapid revision grows. Faults are not static lines on maps, but intricate mosaics of shifting stress. Old models cede ground to dynamic, real-time analyses. Simple predictions vanish, replaced by complex probability maps, leaving only this certainty: complacency is now the greater hazard. California's Office of Emergency Services updates protocols, adding dynamic response triggers that can launch evacuations based on live satellite readings. New building codes aim to adapt with technology, leaving engineers in a constant race against the accelerating cycles of the Earth itself. Even insurance companies overhaul their formulas, updating risk with every satellite pass. Chapter 12. Aftershocks, more than just tremors. The nightmare of an earthquake is not only the first shock, but what follows. Both NASA data and history show aftershocks can roll on for months, even years. Can aftershocks do as much damage as the big one? Physics says yes. Aftershocks destabilize already weakened buildings, trigger landslides, overwhelm emergency services, and strike when vigilance fades alarmed. In zones where strain is highest, each new shock is another spark in a chain of risk. Studies reveal how waves of aftershocks have fractured water lines, started fires, and caused panicked evacuations in past events. Modern emergency planning now includes aftershock resilience zones, mobile clinics, safety inspectors on the move, and temporary housing built to withstand weeks of uncertainty. Disaster risk lingers long after the first tremor, a truth all Californians are asked to remember.
Chapter 13. The Ring of Fire Connection. NASA's research compels us to see California as part of a worldwide system. The Pacific Ring of Fire, the source of most major quakes, reminds us that seismic risk is global. Could the San Andreas Fault's movement trigger ripples far beyond US borders? Geological evidence from the Pacific's past shows that pressure moves and spreads. A major California quake could redistribute strain and influence distant subduction zones. Seismic agencies in Chile, Japan, and New Zealand recalibrate their models when California's strain shifts, knowing events here might eventually echo across the Pacific. International monitoring agencies keep a close watch. Movements along the San Andreas are broadcast and analyzed in real time across the globe. In this interconnected age, when California shakes, the rest of the world listens. Chapter 14. When the ground moves. The satellites still circle above, the data still flows, scientists still watch. Deep below, the plates grind and strain, reluctance growing year after year. Above, cities bustle with daily life, tethered to hope. But with NASA's instruments revealing the truth, strain mounting, pressure rising, the San Andreas waiting with patience forged over centuries, a single external nudge or unseen slip could transform everything in the blink of an eye. A cosmic visitor, a blinding burst, a surge of strain, each a warning, encrypted in the language of geology and the cosmos. Soon, the ground itself may answer. What breaks first? The fault, the cities, or our sense of safety? There is no certain answer. But as science works to keep pace, and as warning signs mount, it's clear that California stands on a razor's edge, with its future wound tightly beneath its feet. If you want to stay informed about Earth's most dramatic mysteries and follow each warning as it emerges, make sure you subscribe. This story is just beginning, and the ground beneath us has many more secrets yet to reveal.